Hello, this is Pascal's triangle. So we're given num rows, and that is the amount of rows we need to make for this triangle. And this is Pascal's triangle, where this number, where any of these numbers are the sum of the two numbers above it. So you can see that in the diagram. So in an example, we're given 5, and we're given an output of a length of 5 rows, and these rows resemble the triangle, as you can see here. So we need to iterate through this amount of times. And every time we iterate, we need to create a new array which resembles our row. And that length is going to be I plus 1. At the same time, we need to be iterating through this array and checking if we're in the beginning of this array or at the end of this array, we're going to insert 1. Right? So what's going to happen when we're down here? We have 1, blank, 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 and then another 1, right? So here we need to do a calculation. If it's not the first or the end of the array, then we're going to check the previous array of j. J is the index of the iteration we're doing inside the array. We're doing j minus 1 plus j. And that will give us the result. And then we just simply return this array. So that's going to be O of n squared time complexity because we're going to have to iterate n amount of times and also create a new array each time and iterate through those, which will be at most n. It will be n minus 1, n minus 2, n minus 3, but that equates to n squared at worst case scenario. And we're also going to have n squared space complexity because we have to create an array for the triangle and also the arrays for the rows.